Hello friends, welcome to Advent Academy. In the last lecture, we have discussed up to question number 11. So we will discuss question number 12 onwards in this particular lecture. So basically, we are discussing the problems on the constraint motion. So let's start our discussion. So what is given in the question is that a particle is tied to a string of length A, okay, is projected from its lowest point so that after leaving the circular path, it describes a free path. So let us draw the circular motion. Okay, it is having a circular motion like this. Okay. So what is being asked in the question is that a particle tied to a string of length L is projected from its lowest point. So let us consider the initial velocity as u. So that after leaving the circular path, so let us consider at an angle of theta 1, it leaves the circular path. That is at theta 1, we have tension in the string becomes 0. Since the tension in the string becomes 0, then the string will get slacked and it will leave the circular path and rather follow a parabolic path. Okay, so what is being asked in the question is that so that after leaving the circular path, it describes a free path passing through the lowest point. So after leaving the circular path, it will pass through the lowest point uh, through a path that is known as a parabolic path. So this is our trajectory that is in parabolic nature. Parabolic nature. Okay. So we have the initial velocity as u. So let us consider the velocity at the starting point of the projectile as v1. Okay, so let us write down the equation of tension and velocity at a random point. So we know that equation for tension and velocity at random theta is given by tension is equal to mu square upon a minus mg 2 minus 3 cos theta, and v square is equal to u square minus 2 ag 1 minus cos theta. So let at theta is equal to theta 1, tension is equal to 0. So this is equation 1 and this is equation 2. So equation 1 becomes 0 is equal to mu square upon a minus mg 2 minus 3 cos theta 1. So we have 2 minus 3 cos theta 1 is equal to mu square upon a into 1 upon mg. So this is equal to u square upon ag. So we have 3 cos theta 1 is equal to 2 minus u square upon ag equal to 2ag minus u square upon ag. So cos theta 1 is equal to 2ag minus u square upon 3ag. Okay, so this is cos theta 1. Let us calculate this is theta 1, so we have this as alpha. Okay, so alpha is equal to, let us consider this as alpha. So alpha is equal to pi minus theta 1. Alpha is equal. So this angle is alpha, so this angle will also, angle of projection of the projectile will also be alpha. Alpha is equal to pi minus theta 1. Okay, so now let us find the velocity v1. So at an angle of theta 1, it will leave the circular path and follow the projectile path. Okay, and it will pass through the bottommost point. Let us write down the equation of trajectory. For this, for writing the equation of trajectory, we need to find the velocity v1. Okay, so how we can find the velocity v1? For this, we have to write down the force balancing equation. So what we are having is that at a random theta, what are the forces acting on this particle? One is lead due to its weight mg. Second one is the resolved part of the weight, that is mg cos theta. Tension and centrifugal acceleration mv square upon a. So the force balancing equation is T minus mg cos theta equal to mv square upon a. This means T is equal to mg cos theta plus mv square upon a. So at theta is equal to theta 1, tension is equal to 0, and where V is equal to V1. So we have 0 is equal to mg cos theta, theta 1 plus m V1 square upon A. So this gets cancelled. So we have V1 square is equal to minus Ag cos theta 1. Okay. So we have cos of theta 1 is equal to cos theta 1. No. Let us write down cos alpha. What is cos alpha? Let us express this in terms of alpha. So we have cos alpha is equal to cos of alpha is equal to pi minus theta 1. So pi minus theta 1. So this is equal to minus cos theta 1. This means minus cos theta 1 is cos alpha. So here we will have, if we replace cos theta 1 with minus cos alpha. So V1 square is equal to Ag cos alpha. So we have V1 is equal to root under Ag cos alpha. So we have V1 is equal to root under Ag cos alpha. Okay, and the angle of projection is pi minus theta 1. So let us write down the equation of trajectory. So the equation of trajectory is given by y is equal to x tan alpha. What we are having is that, so the angle of projection alpha is equal to pi minus theta 1 and velocity v1 is equal to ag cos alpha. Okay, so we have y is equal to x tan alpha minus gx square upon 2 v1 square 2 v1 square cos square alpha. Okay, so we have y is equal to x tan alpha minus gx square upon 2 into v1 square. So v1 is equal to ag cos alpha into cos square alpha. So we have y is equal to x tan alpha minus gx square upon 2. The g gets cancelled. So we have x square upon 2a cos cube alpha. Okay, x tan alpha minus x square upon 2a cos cube alpha. Okay, so let us further simplify this. So, in the question it is being asked that this projectile will pass through the bottommost point. So let us find the coordinate of the bottommost point. So this distance is, this distance will be, this is a, so this is alpha, so this is also alpha. So this value will be a cos alpha, and this value will be, sorry, a sin alpha, no? A sin alpha, and this will be a cos alpha. Okay, so what we need to find is that this coordinate of this point A with respect to this point B. Okay, so let us, I will draw this again. So what is our equation of trajectory? I will draw the diagram again. Okay. So y is equal to x tan alpha minus x square upon 2a cos cube alpha. Okay, so what is we are having is that, so this is our projectile. Okay, so from here at an angle of theta 1, the projectile motion gets started, and it will follow a parabolic path and will pass through the bottommost point. Okay, this is the bottommost point. Okay, so it will pass through the bottommost point. Okay, so this is our, let us consider the velocity. The velocity we are having v1 is equal to ag cos alpha root under. Okay, and alpha is equal to, this is the angle of projection alpha. So alpha is equal to pi minus theta 1. Okay, So the coordinate of the bottommost point will be, so this point is at a distance of, so this angle is alpha. Okay, so in this triangle, this is alpha, so this is also alpha, and this is a. So this distance will be a cos alpha, and this distance a sin alpha, and this distance is a. This whole distance will be a plus a cos alpha. So the coordinate of bottommost point will be a sin alpha or minus a plus, because it is below this point B. Okay, so point A is below the point B. So we are taking this as positive, and this as positive in the y direction, and in negative y direction it is negative. So point A is below the point B. So this will be negative. The minus of A 1 plus cos alpha. Okay. So this is A sin alpha or minus of A 1 plus cos alpha. So this must satisfy this equation of trajectory. So the equation of, sorry, the coordinates of bottommost point will satisfy equation of trajectory. Okay, so we have minus a 1 plus cos alpha is equal to a sin alpha into sin alpha, sorry, sin alpha upon cos alpha. This is tan alpha, no? So minus, let us erase this. Minus x is, sorry, x square is coordinate is a cos, sorry, a sin alpha. Coordinate of bottommost point is a sin alpha. Coordinate of bottommost point a sin alpha or minus a 1 plus cos. This is a square sin square alpha upon 2a into cos cube alpha. Okay. So we have minus a cos alpha equal to a sin square alpha upon cos alpha, minus this gets cancelled, a sin square alpha upon 2 cos cube alpha. This will be equal to a sin square alpha upon 2 cos cube alpha is equal to a into sin square alpha plus cos square alpha upon cos alpha. Okay, so if we take this to RHS, okay, plus a, समझ में आ रहा है? So this is equal to, let us further simplify this. So we have this as a sin square alpha upon 2 cos cube alpha is equal to a upon cos alpha plus a equal to a 1 plus cos alpha upon cos alpha. ठीक है? What we are having is that a times of this a gets cancelled. So we have and this cos cube alpha and this cos alpha. So this gets cancelled to cos square alpha. So sin square alpha we can write as 1 minus cos square alpha, and this is equal to 1 minus cos alpha into 1 plus cos alpha. 1 minus cos alpha into 1 plus cos alpha upon 2 cos square alpha is equal to 1 plus cos alpha. So this gets cancelled. So we have 1 minus cos alpha is equal to 2 cos square alpha. So 2 cos square alpha plus cos alpha minus 1 is equal to 0. So 2 cos square alpha plus 2 cos alpha minus cos alpha minus 1 is equal to 0. This can be further simplified as This can be further simplified as 2 cos alpha 1 plus cos alpha minus 1 plus cos alpha is equal to 0. 2 cos alpha minus 1 into 1 plus cos alpha is equal to 0. So this will not be equal to 0. So we have 2 cos alpha minus 1 is equal to 0. This means cos alpha is equal to 1 by 2. Okay. So what we are having is that what we have found the value of cos theta 1. The cos theta 1 is equal to 2ag minus u square upon 3ag, and cos alpha is equal to cos of pi minus theta 1 is equal to minus of cos theta 1. This will be equal to u square minus 2ag upon 3ag, and this is equal to half. Let us further simplify this. So we have 3ag is equal to 2u square minus 4ag. This has 7ag is equal to 2u square. This means u square is equal to 7ag upon 2. So u is equal to root under 7ag upon. Okay, so the initial velocity is this one. So if the particle is projected with this initial velocity, then it will leave the circular path at an angle of theta 1. After that, it will follow a path that is of parabolic nature. Okay, and it will ultimately pass through the lowest point. Okay, so let us discuss question number 13. Okay, so what is given in the question number 13 is that show that the greatest angle through which the person can oscillate on a swing, the ropes of which can support the twice the personal ropes. Okay, so let us consider the tension in the string as T. Okay, so T being the tension in the string. So T is maximum. The maximum value of the tension is 2 times the weight of the person. So let us consider the mass of the person as mg. So the weight will be m. T max will be 2 mg. Okay. So let us take a force balancing equation at a random theta. Okay. So let us consider this as a rope. So we have given an initial velocity u. Okay. So at a random theta, we have the force balancing equation as, let us consider this as T. So weight is mg. So resolved part is mg cos theta. And this is the centrifugal acceleration v. So we have T minus mg cos theta is equal to mv square upon v square upon a. So T is equal to mg cos theta plus mv square upon a. So when T will be maximum, so T is equal to T max when theta is equal to 0. Theta will be 0. So we have at theta is equal to 0, v is equal to u. So T max is equal to 2 mg as given in question. Okay. So now we have T is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay. So at theta is equal to 0, T is equal to maximum. Maximum value is equal to 2 mg. So 2 mg is equal to mu square upon a minus mg 2 minus 3 into cos theta. Theta is equal to 0, so 1. 1. So we have 2 mg is equal to mu square upon, this is not a, this is L, because the radius is L. Length of the string is L. Mu square upon L minus plus mg. Okay, so we have mg is equal to mu square upon L. This is equal to, therefore u square is equal to Lg. U is equal to root under L. Okay, so the initial velocity is root under Lg. Root under Lg. So the initial velocity will be v is equal to Lg root under. Okay. So let us consider this angle as theta 1 when the velocity is at, when the velocity becomes 0. So this is the highest point of the oscillation. Okay, so let us find the final velocity. So the final velocity is v square. So we have the expression as v square is equal to u square minus 2 lg 1 minus cos theta. So at theta is equal to theta 1, v is equal to 0. So 0 is equal to u square is lg minus 2 lg 1 minus cos theta 1. So we have lg upon, sorry, lg is equal to 2 lg 1 minus cos theta 1. Okay, so this gets cancelled. So 1 minus cos theta 1 is equal to 1 upon 2. So cos theta 1 is equal to 1 upon 2. This means theta 1 is equal to 60 degree. Okay, so this is theta 1, so this is 60 and this is 60. So this whole angle will be 120 degree. This is being asked in the question. Okay, show that the greatest angle through which the person can oscillate on the swing, the ropes of which can support twice the person weight at rest is 120 degree. So the greatest angle is 120 degree. Okay, so let us solve the part 2 of this question. If the ropes are strong enough and he can swing through 180 degree. Okay, so he can swing through 180 degree. So this is 90 and this is 90. So this is theta is equal to 90 degree. This is theta is equal to minus 90 degree. Okay, so we have the final velocity v square is equal to u square minus 2 lg 1 minus cos theta. So at theta is equal to theta 1, sorry, at theta is equal to 90 degree, v is equal to 0. So we have 0 is equal to u square minus 2 lg 1 minus 0. So u square is equal to 2 lg. So u is equal to root under 2 lg. Okay. So now what is further given in the question is that if v is the speed at any point, so let us consider a random theta. So v is the velocity at v is the velocity at any point. Prove that the tension in the rope at that point. So let us consider the tension as t. So we have t is equal to m u square upon l minus mg 2 minus 3 cos theta. Okay, this is the tension at a random point. Okay, so now we have the velocity at this point. So the velocity at this point, the velocity is equal to initial velocity u square minus 2 lg 1 minus cos theta. Okay, so we have v square is equal to initial velocity is 2 lg. So 2 lg minus 2 lg plus 2 lg cos theta. So this gets cancelled. So we have cos theta is equal to v square upon 2 lg. So let us put this in tension. So tension is equal to m upon l into u square is equal to 2l minus mg 2 minus 3 into v square upon 2l. Let us further simplify this. So we have t is equal to, this l gets cancelled. So we have 2 mg minus 2 mg plus mg into 3 v square upon 2 lg. This gets cancelled. So this g gets cancelled. So we have t is equal to 3 mv square upon 2l. This is the tension at any point. Okay, at that point is 3 mv square upon 2l. This is the asked in the question. No? What is asked in the question? If the ropes are strong enough and he can swing through 180 degree and v is his speed at any point, prove that the tension in the rope at that point is 3 mb square upon 2l, where m is the mass of the person and l is the length of the rope. Okay, so we will discuss further questions in next particular lecture. Thank you.